Hello everyone, Mr. Love here, coming to you from the Diesel Lab. Today we're just going to be doing a quick little video here. I'm doing a load test on our little 12-volt batteries here. Let's get started, everyone. So for our little batteries here, just a quick little review. Remember, inside our batteries here, we have 6 cells made up of these lead plates. Surrounding these lead plates is a little mixture of water and sulfuric acid. It's about 65% water, about 35% sulfuric acid. So we got 6 of these cells in here. Each one of these cells has 2.1 volts. So a fully charged 12-volt battery is actually 12.6 volts. If we actually get down to the actual 12 volts, which they're called, it would actually only be about 50% charged. So when we check our batteries, we're going to make sure they're fully charged before we do a load test on it. So we could hook it right to our VAT28 right now, do the test, but we'll just grab a voltmeter real quick, just to do a quick little check on here. We'll put it on 12 volt AC range here, and we'll check our batteries here. Okay, so right now we're at 12.64 volts here. So this is a fully charged battery. Right now, this battery right here, they're hooked up in parallel. So when I'm hooked up in parallel, we still get 12.6 volts. We just have more amps. Okay, so right now we have our batteries right here hooked up in parallel here. We have multiple batteries hooked together. Right now we just have 2 batteries hooked together, but you know, in some of our bigger diesel stuff, we might have 3, 4, 5, 6 batteries all hooked together in parallel here. Even though they're all hooked together in parallel here, they're still going to be 12 volts. What happens is we increase the cold cranking amps for each one that we hook onto there. So each one of these is 925 cold cranking amps. So the 2 of them hooked together right now, we have 1,850 cold cranking amps here. We added another battery hooked on here in parallel, we add another 925 to it. So obviously our little load tester here can't really handle 1,850 cold cranking amps. So if we do have them hooked up in parallel like this, we're going to have to unhook them off of here. We have to take the cables off just so we can test one battery at a time here. Whenever we unhook our batteries, make sure you keep track of where the wires and stuff go on them. You don't want to start mixing up where they go, especially if you pull the batteries out. You don't want to accidentally hook the negative to the positive in our 12-volt systems. Remember, if we hook them up in series from going to negative to positive, then we're actually adding more voltage to it. So we do that real quick to show you. So I'll take my negative from this battery here, go over to the positive of the other one. Now when I actually test my voltage here on our battery, you see now we have 24 volts, so 24.56 volts coming out of it right now. So we definitely wouldn't want that in our 12-volt system. We burn out our computer or something. So I'll take this back off for now. Okay. So we're going to do a quick little load test on our battery here. I'm just going to put these little nuts on here just so I have a better little grip with my cables here. So we know this battery is fully charged, has over 12.6 volts that we just saw. I'm going to take my negative ground clamp and hook over on my negative terminal there. And take my positive clamp here, hook to the positive side. Now you can see here on my load tester, I'm above 12.5 volts right now. So that's right where I want to be. What I'm going to do now is I'm going to turn this little knob right here, and it's going to put a load on this. There's a carbon pile inside here. It's basically going to put an amperage load on there, however much I want to put on. What determines how much of a load I put on there is my cold cranking amps of my battery. I want to do half the cold cranking amps of the battery. On here, my battery is 925 cold cranking amps. I'm going to put a load on there of about 460 or so. So I see that by the actual load range right down here in the red. So I'm going to turn my knob slowly. It's going to start applying the load. I'm going to watch my voltage drop. So right there, I got 400. around 450 amps on there. I'm watching my voltage here. My voltage is going to go down a little bit. I'm going to keep that load on there for 15 seconds. What I want to do is make sure that it doesn't go below 9.6 volts in those 15 seconds there. Okay, 15 seconds on there. It didn't drop down below 10 volts, so the load test on that battery passed. So that's a good battery. Hook up to my other battery here. This one here is a little bit older battery that we pulled out of a truck. This one's from 2017, so it's kind of pretty much at its life expectancy there. You see here, we're not quite at 12 volts here. This battery was on the charger overnight, so we know right off the bat that this battery's no good. It's been on the charger overnight and it's still not even at 12 volts there. To really do our accurate test, we want to make sure our battery's fully charged. That way we give it, all the chance we can. So just for the purpose of this, we'll give her a little load test right now. This one here's 1,000 cold cranking amps. So we're going to put 500 amps on it for 15 seconds. Make sure it doesn't drop below 9.6 volts. Slowly apply our load onto there. There's 500 amps. And it's climbing down right here. We're already down under 9. We're almost at 8 volts. 4 seconds on our test here. And we're down to about 8 volts there in our 15 seconds. So we know that battery's getting pretty weak there. Whenever we have a weak battery, puts more of a strain on our alternator and stuff like that. So this time of year, especially with it being colder outside, we want to make sure we have good batteries in our vehicles. Sometimes we might even get a battery that has 12.6 volts or higher in it, and we put a load on it, and it'll drop right down if it has any bad cells inside there. We might get it to drop right down to 0 when we apply a load to it. So that's why it's important that we actually do a load test on our batteries, not just a voltage test on them. Just to recap, we put a load on this with our little carbon pile load tester here. You get load testers that come in many different ways. We have a fancier electronic one here. Sometimes you'll see a small handheld one. Sometimes it might just be a small digital one that doesn't really put a big load on it. It puts kind of a voltage spike going through it there to measure the load that it can handle. So the best thing to do is an old carbon pile. I like these the best. This one here is a VAT 28. We also have a VAT 40 here. I can put a little bit more of a load on our batteries. But for what we're doing today, this one works pretty good. So remember, what determines how much of a load we put on there is how many cold cranking amps our batteries are. We want to do half the cold cranking amps of the battery. So if it's 1,000 cold cranking amp battery, we're going to do 500 amps for 15 seconds. We're going to put that load on there for 15 seconds. We're going to watch our volt gauge. We're going to make sure it doesn't go below 9.6 volts in those 15 seconds. Usually if we have a real bad battery, like I said, it's going to drop down instantly, go right down, below 4 or 5 volts, and we know right off the bat that one's shot. If you get one that's, kind of borderline, best thing to do is to charge it back up overnight and test it again the other day, next day. Our batteries, they're really only good for about 5 years. After that, you're kind of on borrowed time. What happens is sulfate starts to build up inside our batteries, kind of scales up inside there. They'll start to push our little plates apart that we have here. And all this stuff kind of breaks off of it. We have another battery over here. We kind of look down in. We can see a lot of sulfate build up in this one right here. If you take a look down inside that battery, see all the plates are pretty much dumped up together there. All the sulfate and scale and stuff that's on there. It's definitely a bad battery. That's it for today. Thanks for watching. Catch you on the next one.